Welcome back to the CompTIA SecurityX series. In this session, we will cover topic 3.5.3, industry-specific challenges and characteristics of specialized and legacy systems. Industry-specific challenges. Every industry faces unique cybersecurity risks. Let's look at some of the most critical ones. Utilities, energy, water, and power systems. These rely on SCADA and industrial control systems, many of which were built decades ago without modern security in mind. They are often remotely managed and are prime targets for nation-state cyber attacks. Example: in 2015, hackers attacked Ukraine's power grid, leaving hundreds of thousands without electricity. Transportation. Airlines, railways, and shipping companies often run on outdated, deeply integrated systems. Updating them is complex, and any downtime can disrupt entire operations. Example: the Colonial Pipeline attack in 2021 caused massive fuel shortages and transportation chaos across the U.S. Healthcare. Hospitals use obsolete medical devices like MRI machines and infusion pumps that often run old operating systems. They are extremely vulnerable to ransomware, and attacks can put patient lives at risk. Example: the WannaCry ransomware in 2017 crippled the UK's National Health Service, forcing hospitals to cancel surgeries. Manufacturing. Factories depend on industrial control systems designed for uptime, not cybersecurity. This makes them attractive for sabotage or intellectual property theft. Example: Stuxnet in 2010 was a sophisticated attack that sabotaged Iranian nuclear facilities by exploiting their control systems. Financial services. Banks and financial institutions face constant phishing, fraud attempts, and DDoS attacks. Many still rely on legacy mainframes for critical transactions. Example: in 2016, hackers stole $81 million from Bangladesh Bank by compromising the SWIFT payment system. Government and defense. These sectors are frequent targets for espionage and nation-state actors. They use legacy systems that often store classified data, but cannot be upgraded easily due to strict regulations. Example: the 2015 U.S. Office of Personnel Management breach exposed personal information of over 22 million federal employees. Characteristics of specialized and legacy systems. Now, let's explore why these systems are so difficult to protect. Unable to secure. Legacy systems often cannot be patched or updated without breaking functionality. For instance, a SCADA system controlling a power grid can't easily be taken offline for updates. Obsolete. Many of these systems are running on outdated operating systems that vendors no longer support. For example, ATMs running Windows XP long after support ended. Unsupported. When manufacturers stop providing updates or security patches, these systems are left exposed. This is common with old PLCs used in factories. Highly constrained. Some specialized devices lack the processing power or memory to support modern security tools like antivirus or encryption. This is common in embedded systems inside medical devices. Conclusion: legacy and specialized systems are critical for our infrastructure, healthcare, transportation, and national security, but their age, complexity, and importance make them prime targets for attackers. Cybersecurity professionals must carefully balance security with operational needs, often using compensating controls like network segmentation, strict monitoring, and physical security to protect these systems until they can be upgraded or replaced.